Now let's see how to calculate the expected unit short for a normal distribution, for the case where the demand is normally distributed. So what we're going to do is use this loss function, this LQ, and again that's the expected amount that the random variable x, the demand, exceeds a given threshold value q. This is also called the expected unit short per replenishment cycle. So I show you the two equations here in terms of the discrete case and the continuous case. And we're going to focus in on the normal distribution, which is, again, a continuous variable, obviously. And what we're going to do is introduce this unit normal loss function. So it is a loss function that was specifically designed for the unit normal. And we're going to call that G sub k. We're going to use a lot of G sub k in the next couple weeks. And so G sub k is essentially, given a k, it'll tell you for the unit normal function, the unit normal distribution, what the expected unit short are. And then I multiply that by my standard deviation of the demand, and that'll tell me my expected unit short for my distribution. So to use this function G sub k, I'm going to have to transform my distribution into the standard normal distribution, or the unit distribution, where the mean is 0 and the standard deviation is 1. And so I'm just simply going to transform, and it's equal to the q minus my mean of my distribution divided by the standard deviation. And in spreadsheets, whether it's Excel or LibreOffice, the function is just the norm s inverse of the critical ratio, and that will give you the k value. Now the unit normal loss function seems complicated, and it's always a little confusing for students when they first start using it. What it turns out to be, though, you can look at this G sub k, and it's really just the probability density function minus the k times the cumulative density function. In spreadsheets, I can create this with this simple little expression, whether it's LibreOffice or Excel, so you can plug this in to a spreadsheet and always calculate what the G sub k is for a given k. But I can also use the tables. So in our standard normal tables that we provided you, not only did we give you the probability that x is less than k, which we used to figure out for the critical ratios, we also gave you a column G sub k, which is the unit normal loss. So let's do a simple example to illustrate how to use this. Suppose that I've got my demand and it's normally distributed. Let me just draw a little picture here. And the mean is 160. And my standard deviation is 45 units. And suppose I ordered a Q, and my Q is 190 units. So I want to know, what is my expected units that I'll be short for each replenishment cycle? Well, how do I figure this out? First step, find the K. I want to transform it. So my K is going to be equal to my Q minus the mean, the mu, and then it's going to be divided by the standard deviation. So 190 minus 160, and divide that by 45, and I get a K of 0.67. So then I look at my table, find 0.67. Here we go, it's right down here. And I find that my G sub k, looking down this column, is 0.1503. So I know for the unit normal distribution that it's going to be 0.15 units short, or 0.1503. I multiply that by my standard deviation of the demand, the sigma, and that gives me 6.76. So for this simple example, I know that if my demand is distributed normally with a mean of 160 and a standard deviation of 45, and I have 190 units ordered each time or on hand, then I can expect to be short 6.76 units each replenishment cycle. So that's how you can calculate using the tables to find your G sub k, or your unit normal loss, and turn that into expected unit short. Now let's apply all of these things to solve the NFL jersey problem.